Hi everyone, this is the solution to example 2 of plastic beam analysis. In this problem, we still have a fixed beam, but now we have two loads, one of W and one of 3W. So the only thing we know is the load on the right is 3 times the load on the left. And again, we need to find what is the maximum load that we can put in this structure without causing it to collapse. Again, the plastic moment in this case is 60 kilonewton meter, which again we obtained from the plastic section analysis. That was the previous topic we talked about. Now, in this particular example, we don't know for sure what should be the right collapse mechanism. In this case, we actually need to study two collapse mechanisms. So I'm going to first talk about the first one, which would have a plastic hinge on the left and the right support, and then a plastic hinge underneath the load W. The second collapse mechanism we can talk about, it's the one that also has plastic hinges at the support, but now has the other plastic hinge underneath the load of 3W. Now you could say to me, Luis, doesn't it make sense that the second one is more critical because we have a bigger load? And yes, it does. It does make perfectly sense. But in this particular example, we're going to calculate both so you can see what happens when you have more than one collapse mechanism and how do you choose. But if you already can understand that the second one will be the critical one, then fantastic. And you don't have to calculate the first collapse mechanism in this case. But okay, let's learn how to calculate both, and then you'll see what do I mean by this. So let's start with the first one. So similar to before, we're going to assume a certain rotation theta on one of the supports, and then we're going to draw the collapse mechanism all together. Now, if that rotation there is theta, that means that the displacement underneath the load W is theta, and here is our load W. That means that this angle here has to be equal to theta over 3, so you get the same displacement on both sides, and that also means that this angle here is theta, and that angle there is theta over 3. The only thing we need to calculate here is the displacement underneath the load 3W, which is that displacement over there, and in this case should be theta over 3 times 1, so it's just theta divided by 3. So now we're in a situation to calculate our collapse load. First of all, we have W times theta on the left side in green, plus now 3W times theta over 3, which is the other load times its displacement. This needs to be equal to all the plastic moments at the hinges times its rotation. So we have a plastic moment here, another one, two more here, we have another one here, and now we're in a situation to calculate this. So the first one on the left should be MPL times theta, plus we have another one MPL times theta at the second hinge. We also have in the second hinge an MPL times theta over 3, and now we have another MPL times theta over 3 at the right support. Again, in these equations, the thetas always simplify. We're going to get rid of all of this, which now we can simplify this as the first part is W plus 3W over 3, that's just 2W. This is going to be equal to 1 MPL, 2, and this is a third and another third, so 2 plus 2/3 is 6/3, so it's 8/3 MPL. Okay? Which means if we know that MPL in this case is equal to 60, that means that W is going to be equal to 8 times 60 divided by 6, which should be equal to 80 kilonewton. So the first collapse mechanism has a collapse load of 80, which means the load on the left needs to be 80, the load on the right needs to be 3 times 80, which is 240. Now, let's calculate the collapse mechanism number 2, now that we figured out that in this problem we need to calculate 2 of them. And this one looks very similar. Let's just draw it. But now the second hinge is underneath the load 3W. So similar to before, we're going to start with a rotation of theta. And here we're going to close our collapse mechanism. If that's theta, this also is theta. And the displacement underneath the load needs to be theta times, and the distance is 3 meters. So that's going to be 3 theta, and if that's 3 theta, that means that this angle here also has to be 3 theta, because we're going to multiply by 1 meter here to get 3 theta, and don't forget this one is 3 meters. Okay, so now we're in a situation to say that this also has to be 3 theta, and in all of these hinges we need a plastic moment that causes that hinge. So we need these moments to be there so we can calculate their work. Another thing we need is the displacement underneath the load W, which is also theta because the distance to the left is 1, so 1 times theta gives you just theta. Now we can calculate our equation. So the first one is W times theta, on the left in green, now plus 3W times 3 theta. Now that's the other load. Now in terms of moments, we have one moment that is MPL times theta, and I'm going to multiply by 2 to account for this one as well. So we have this one here, and then we have this one here. So that's times 2. And now I'm going to take the other one, which is also times 2, so plus 2 times, and this should be MPL times 3 theta. This accounts for the other ones. Again, we can simplify all the thetas, so this all disappears, and we can now get that the first part should be W plus 9W, so it's 10W, equals, and now how many MPs we have? We have 2 plus 6, so we have 8 MPL. If we remember that MPL is equal to 60, this means that our W should be equal to 48 kilonewtons, which is the collapse load of this mechanism. And now we get to the interesting part of this type of problems, which is how do we choose which is the correct collapse mechanism and which is the one that happens first. So if we solve the first one and we realize that we need a load of 80 to break this beam, right, to cause the collapse of this beam, and we calculate the second and we realize we need 48 to break this beam, that means the 48 is a critical one. That means that this beam will never ever get to 80 because it breaks at 48. So to finalize this type of problems, you just have to write down that mechanism 2 is critical, and then we can write that W is equal to 48 kilonewtons. So what did we learn in this problem? We learned that the load that causes the collapse of this structure is equal to 48, and the collapse will look exactly like the one we calculate in the collapse mechanism number 2. So that's the idea behind these problems. I hope this made some sense, and thank you for watching, and have a nice day.